So today we're going to talk about constant expression in C++. It is one of those very beautiful keywords that if you know how to use it in a smart way, it's going to basically help you to get rid of a lot of redundant assembly instructions in your application. What do I mean by that? To showcase the beauty of constant expression in C++, we're going to see some very, very simple examples, but this is going to give you the key idea that how and where and when you need to use it in a smart way, let's say. Right now I have my main.cpp right here. We're not doing anything, we're just returning 0. If I want to compile this, I say G++ minus capital S because I want to inspect my assembly instructions, main.cpp. The standard is going to be C++11. Oh, by the way, constant expression is also part of the modern C++, which means from C++11 and onwards. And that is why I want to explicitly say C++11 should be my standard here. And then I want to activate level 1 optimizations, and I want my output to be called as output.s. If I open this file, then you see that I only have right now 12 sort of lines for this assembly code. Remember this value 12, and we're going to come back to this. So the first thing to know about const expressions in C++ is that you should not confuse it with constant qualifier. For example, if I say const double d equals 10, what am I saying here? I'm defining a constant variable called d. I must initialize it, so this step here equals 10 is a must. And the property of const is that I cannot basically, your variable is not mutable, so you cannot assign, for example, 5 to d. Right now you can see that Clang is immediately complaining. It says that cannot assign to variable d because we have const qualified. So, okay, so I know what const is. But having const here doesn't guarantee that your variable is going to be sort of known at compile time. Imagine that I have such a structure. I have a function here, double. I have get value, and this one, for example, gets a parameter. Doesn't really matter. And what it does is it returns x times 42. And then I'm coming down here, and instead of this 10, I'm going to say get value. And I'm going to pass, for example, I don't know, 10. Value 10. Right now you see that Clang is super happy. He doesn't care. It's a const value, but we have a function call right here. And he doesn't care. He's super happy. So let's take a look at compilation here. If I recompile this and take a look at the instructions, in the beginning we had 12 lines, right? Now we have 23 lines of instructions. So it seems like we have the get value signature function here. We have a bunch of instructions related to this function. And so we got a little bit of overhead after adding that function there, right? So let's go back here. Let's use const expression now. If I use constant expression here, you see that immediately Clang is uncomfortable. He's throwing an error here. Let's take a look at it. It says const expression variable d must be initialized by a constant expression. So it seems like get value, this function call, is not a constant expression. So how can we make this a constant expression? Of course, you're not only limited to use const expression for variables, you can also mark your functions with that. So this function specifically, because it has a single line sort of return statement, it's a very good candidate to be used as to be marked as const expression. So if I say const expr, right now you see that immediately Clang is very happy. Now he's not complaining. You might say, oh, we haven't done anything special. We just added 2 constexpr keywords there. Let's see what magic happened behind the scenes. If I compile this and I take a look at my output, voila. Again, back to 12. So I have 0 overhead. So now you start to realize, to basically see the beauty of constant expressions. Where else can I use const expressions? Of course, not only with functions, or variables, you can also use constant expressions in your user-defined data types or data types or classes. Remember the particle class we had before? Let's define it again. We had a member, if you remember, we had a member called d as diameter. So this is going to be diameter. And then we had a constructor with double diameter. We can also initialize our d as diameter, and that's my constructor. And then let's also define a getter function. Let's say double get diameter. And this is not going to do anything but just returning the variable d. Now we come down here, we inject a particle P1 with diameter of 4 millimeters. And right now you see that Clang is complaining, of course, because everything is private here. I mark it as public, this stuff. So now Clang is happy. So we have a very simple sort of user-defined type. It has a constructor. Oh, by the way, I can also avoid or disallow implicit conversions by adding explicit here. So there we go. I have a very simple constructor. I have a very simple getter function. It just has a simple one statement return statement. So let's compile this. Take a look at output. Now from 23, we jumped into 49 lines of instructions, right? So 49, remember 49. If I come back here, let's say this thing is quite simple. It's a good candidate to be used as constant expression. So I can throw in a const expression here. And this thing as well, it's just a getter function, which has one line return statement. Let's also mark this one as const expression. And by the way, if I want to be correct with const correctness in classes, I need to also add a const here. This means that my this is not going to change, the method is not going to change the status of the particle class. This means I can, if I throw an object of particle class as const reference, this method is still accessible. Anyways, let's just add also another const expression keyword here. So we haven't done any magic. We just throw in some const expressions here and there. Let's go back, compile this, and take a look at the output. This is the magic of constant expression. So from 49 lines of instructions, now we are back again to 0 overhead again. So this is constant expression in a nutshell. Now you understand the beauty of constant expression. And what does it really do? So when we are using constant expression, what we are saying is that, hey, compiler, if you have the chance to basically find the value of a variable, or you can compute or evaluate a function call or a variable or whatever that could be done at compile time, then you must do it. And you can see that this simple design of our application basically brought us into 0 overhead. So all these lines of code here basically is equivalent to main function return 0. You remember initially we had only 12 lines of assembly code, right? So this is the beauty of constant expressions in C++. This video was very, very short. If you're interested in more information, I also attach in the description of this video the paper by Gabby and Bjarne from 2010. And I hope you learned something from this video and hope to see you in the next one.